Well, hello and welcome to round two. I don't have a lot of examples left, but I definitely think that to just keep pushing through, like, this was a lot of information. And so if you needed a break, it'd be easier just to chunk it like that. Okay. Excuse me, gosh. Okay, we are being asked to find the exact value. Again, that means no calculators, so we're going to have to problem solve here. Well, looking at A, I'm not too worried because I know the inverse sine of rad 3 over 2, and I know the inverse cosine of 1. How do I know that? Because inverses are last unit and the unit circle. Okay, so let's just fill that in. So if you think about the inverse sine of rad 3 over 2, it's positive, so I'm in the first quadrant, and sine will have a value of rad 3 over 2 at 60 degrees. Good. Use degrees, use radians. It's not going to matter because we're going to end up using the sum formula anyway. And then the inverse cosine of 1 is just 0. All right. So then the sum formula is sine of the first angle, cosine of the second, same sign plus, cosine of the first, sine of the second. Okay, and then plug in what you know. We know that sine of pi over 3 is rad 3 over 2. The cosine of 0 is 1. The cosine of pi over 3 is 1/2, and the sine of 0 is 0. So this just works out to be rad 3 over 2. Yeah, easy enough, totally. Okay, cosine of the inverse tangent of 4/3. This definitely is not looking like something we know. So right away, I'm going to say that this is the cosine of alpha plus beta, because I need to figure out the triangles that they came from. And the angle measures don't necessarily mean a lot to us. We just know that alpha is going to be in the first quadrant because it's inverse tangent of positive. Okay, so let's draw that. Tangent is opposite over adjacent. It's a 3, 4, 5 triple, but you're more than welcome to work out the Pythagorean theorem if you need to. And then the inverse cosine, so beta, is positive. So yeah, we're in the first quadrant again, but we're a different triangle. It is 12 for adjacent, 13 for hypotenuse, and 5, 12, 13 triple. All right, so then we get the cosine of alpha, cosine beta, because we're going to use the sum formula, minus, because it changes signs, sine of alpha, sine of beta, and use the triangles you built, just like we did in example 3. The cosine of alpha is, if I look at alpha, 3 over 5, times the cosine of beta, which is 12 over 13, minus sine of alpha, which is 4 over 5, times sine of beta, which is 5 over 13. And then multiply across. So we get 36 over 65 minus 20 over 65. If we subtract, we're getting 16 over 65, and we'll leave it as that. Easy, especially considering we just did example 3, right? Yeah. Okay, so cosine, and again, I don't know an angle measure that's going to give me a sine value of 2/3, but it doesn't matter, you guys. It does not matter. Give it an angle. Let's call it alpha. Let's call it beta. Create the triangles. Inverse sine of 2/3. Okay, 2/3 is positive, so we're in the first quadrant. The sine is 2/3. If I use the Pythagorean theorem, I end up with 9 minus 4. This is going to be our square root of 5. Tangent. Tangent's negative. Inverse means I'm in the fourth quadrant, so beta's in the fourth quadrant. Tangent is opposite over adjacent, and yes, that 3 is going to be negative. 3, 4, 5 triple. Okay, here we go. So cosine sum formulas: cosine of the first angle, cosine of the second, change the sign, sine of the alpha, first angle, sine of beta. All right, look at alpha. Cosine of alpha is rad 5 over 3 times cosine of beta, which is going to be 4 over 5, minus the sine of alpha, which is 2 over 3, times the sine of beta, which is going to be negative 3 over 5. Neat. All right, if we multiply, we get 4 rad 5 over 15 plus 6 over 15 Can't really combine anything except the denominators, so 6 plus 4 rad 5 all over 15, and 6, 4, 15 don't have a greatest common factor other than 1, so that's our final answer. Excellent. All right, last example. And I know you might be thinking, wait a second. There's 6. Yeah, cross it out. Okay, do me a favor and just cross it out. So let's just do example 5 and call it a day. All right, this one is established, which means we are proving. So it's great because it ties in with our last section and the stuff that we're learning new. Remember, when you're proving an identity, you always want to start with the side that has the most to work with. So for A, I'm definitely thinking it's the left because it could be a sum formula. And I'm going to write it out as it is. So cosine pi over 2, cosine theta. Even though I don't know what theta is, I'm hoping that that won't be an issue. Okay, and then we're going to subtract, because it changes signs, the sine of pi over 2, which is the first angle sine of theta. And you can only manipulate one side at a time. Don't forget that. So then fill in what you do know. Cosine of pi over 2 is 0. Okay, so 0 times cosine theta minus sine of pi over 2 is 1. Oh, hey now. So then we're left with negative sine theta is equal to negative sine theta, and we're done. Boom. Excellent. All right, I feel like I say excellent a lot. You guys making fun of me? Are you tracking me like you did with guys with the other teacher who shall not be named? Yeah, rude. All right, so for B, tangent, let's do the left side, because again, there's more to work with. So we have tangent of 2 pi, same, so subtraction, tangent of theta. Don't worry that we don't know what theta is, okay? Just like the last one, it might work out. If it doesn't, we'll reevaluate. That's what's great about proofs, is that you can reevaluate. So some of you are like, no, I hate that. So then we get 1 plus tangent of 2 pi tan theta in the denominator. Okay, remember, sine over cosine, same over change. So tangent of 2 pi, tangent is sine over cosine. So at 2 pi, sine is 0, cosine is 1. So that means we have 0 minus tangent of theta all over 1 plus 0 times tangent of theta. In the denominator, that just becomes 1. So we have negative tan theta is equal to negative tan theta. And we are done. Rad. All right, guys, 2 homework assignments. I split it up so you can attempt one and then attempt the other, but, you know, obviously do at your leisure. And I did promise, I promise that I picked meaningful ones, and I tried to spread out the love. All right, take care.